Good morning. I'm Ed Swan, one of the general chairs of IEEE VR 2020, and I am very pleased to introduce our keynote speaker for the morning, Dr. Susan Persky of the National Institutes of Health. Dr. Persky is an associate investigator and unit head within the Social and Behavioral Research branch of the National Human Genome Research Institute, all of which are part of the National Institutes of Health. She earned a bachelor's degree in psychology from Northwestern University and master's and PhD degrees in social psychology from the University of California, Santa Barbara. At the National Institutes of Health, she built the Immersive Virtual Environment Testing Area, which is a VR-based experimental research lab, in 2006. And there, she splits her effort between providing leadership and conducting research that investigates the communication of new genomic knowledge about common health conditions, such as obesity and diabetes. She has published extensively in the areas of virtual reality research applications, health communication, and genomics. I will remind the audience to type your questions in Slido, and we will also be monitoring the Twitch stream. Dr. Persky.
Okay, I want to thank the organizers for inviting me to give this presentation and for everybody's hard work to take this conference online. I can tell it was an enormous effort when this became clear that the conference couldn't be held in person. So thanks to everyone watching from wherever you are. We're all in Atlanta in our hearts. I hope everybody is staying safe and healthy. I want to send a few more thank yous to my colleagues and collaborators, those who contributed slides, and those who made possible the research that I'll be discussing today. So you might recognize this quote from my title. If you do, I would not hold it against you for thinking that we're going to talk about the Spider-Man VR game today, which is not exactly my plan. But what I'm going to talk about is actually relevant for the Spider-Man VR game, and it's really relevant for all VR experiences. Today I'm going to talk about the behavioral data that arises from use of VR. So we're going to discuss the exciting and the important things we can do with those data from a research and from a healthcare perspective, but also we're going to discuss the other side of the coin. So why do we need to protect these data from uses that don't serve the public good and from uses that could lead to public harm? So let's start off. We'll get a shared definition of behavioral data. So first and foremost, these are the data that we essentially need to run a modern VR system. I'm going to use the example here of a 6DoF system where we have position and rotation data. We can add a couple hand trackers into that equation. And then we can start to think about all of the additional data streams that are technically possible, but not usually routinely integrated right at this moment. We just want to future-proof our thinking a little bit. So we can think about things like additional trackers, like eye tracking, physiology, things like EKGs, skin temperature, skin conductance. We can think about brain activity, EEG, FNIRS, brain control interfaces, and we can think about voice prints. So things like the characteristics of our voice as we speak. Now, we have all these data, let's consider them over time. We can sample them during our VR experience up to say 90 times a second. A calculation by Jeremy Bailenson suggested that with the current systems, we could be looking at about 2 million data points from 20 minutes of VR activity. But given all of these other potential data streams, this could be really the tip of the iceberg. So a wise colleague once told me that audiences only remember 3 things once you finish talking. I've been to a lot of talks, this pretty much checks out. So here are your 3 things. I'm going to give them to you right now. Okay, so number 1, behavioral tracking in VR is powerful. Number 2, what provides power for social good can provide power for social ill. And number 3, there are ways to mitigate potential future harms. So I'm going to start at the beginning and talk about first the great potential of behavioral tracking in VR. Why are we doing this? So I'm going to start by looking at the power of VR behavioral movement tracing in the domain where I do a lot of my work. So this is using the data to infer psychological states and to predict behavior. Now, in this domain, there are a couple of really common ways to look at behavioral tracking data, been used for several years. We can look at these data through one of two lenses. So the first is looking at location data to indicate proxemics or interpersonal distance. So the size of our sort of personal space bubble that we leave between ourselves and an interaction partner. So in this case, it's going to be a virtual interaction partner, obviously. The second is gaze direction. So what's in your field of view at any given time in VR? This can be used as a proxy for eye tracking, since we're not typically using eye tracking all that frequently yet. And it can be in an interpersonal interaction, a proxy for actual sort of person-to-person eye contact as well. Now, before we get into this, I want to point out one important note, which is that for both of these measures, and really for every other measure of behavior in VR, it's important to remember that context is king, right? So if we think about our gaze-centeredness measure that I just talked about, the psychological or the practical meaning of a view-centeredness measure depends completely on what it is that I might be looking at in a VR environment. So if I'm using this measure to assess behavior in interpersonal interaction, in a virtual food choice environment, a virtual classroom, the measure has to be absolutely interpreted as a function of the VR content. So use of VR for behavior tracing has been applied in several domains. We can broadly group these into a few areas. So I'm going to talk about three today. The first one is interpersonal bias and discrimination. So this means prejudice against or differential treatment of members of a particular social group. As you can imagine, this is not something people really like to report about to researchers. Sometimes people aren't even able to report about their own biases. So having this kind of psychological process being able to be picked up by movement in VR can be especially useful. So what I'm going to do is to start with a more in-depth example of what this looks like using research from my own lab. Now, I'm a behavioral scientist from the Genome Institute at the National Institutes of Health, as you heard. So a lot of what I'm going to talk about today will be in the context of health and medicine. But I want to point out that these concepts are absolutely applicable to many other domains. So education, training, entertainment, so on and so forth. So the example we'll first consider has to do with investigating factors that affect interactions between patients and healthcare providers in clinical settings. But why? Why are we looking at behavior here in these virtual clinical environments? Well, the reason that I do this in my work is because communication between patients and healthcare providers is so crucial to patient health. And because we know there are differences in how patients are treated based on characteristics like their race, their gender, their weight. And so we want to know how to train healthcare providers to interact with their patients in ways that don't make patients feel stigmatized or discriminated against. So we can use behavior as a window into these attitudes and beliefs and emotions that are in play during these medical visits from the relative safety of a simulated visit as opposed to real ones. So for the research project I'll talk about first, the aim was to explore the effect of communicating about genetic factors that contribute to obesity risk among medical students. And we looked at how this influenced medical students' stigmatization of the patient and their clinical decision-making as well. So our medical students came into the lab. They were randomized to interact with one version of a virtual patient. You can see her up here on the slide. She was identical in every way, what she said, her nonverbal behavior, et cetera, except for the factor we were interested in, which was, of course, in this case, her weight or her apparent body size. So for part of our outcome measures, we looked at the med students' gaze behavior during the visit. So how much time did they spend looking at the patient's face as opposed to other parts of her body or other elements in the VR environment? And again, this was sort of proxy for eye contact in the medical visit, and it indicates engagement with the patient. So we'll look at a graph of this eye contact behavior. What we see is that our participants made less visual contact with the obese version of the patient than the lean version of the patient. Now, those medical students who got genetic information about genetic factors contributing to obesity actually showed restored eye contact in these engagements. So for comparison's sake, we can look at patterns that we found in how medical students responded to questions after the visit. So here we're looking at negative stereotyping, so negative beliefs about people with obesity as a group, and how students applied these beliefs to this individual. And we actually, in this case, see a similar pattern. So when the patient was lean, Medical students negatively stereotyped her less than when the patient was obese. But those who got the genetic information showed negative stereotyping that was significantly reduced. So in this case, looking at the gaze behavior told us that medical students exhibit more bias against a patient with obesity, but that genetic information reduced that bias. So now let's look to some other studies and see what kind of stories behavioral data told about bias and discrimination. So a little more data from my lab, because we all like our own data. So in another study, we looked at interpersonal distance that happened during a virtual medical visit. This time we were examining patient behavior as opposed to provider behavior. So what we found was that patients who got health information that they felt was stigmatizing moved further away from the doctor who was providing that information over the course of the conversation. So in this case, body movement indexed participants' perceptions sort of that the doctor was biased, the negative evaluations of that doctor. Now, on a more basic level, another study from a group in Moscow showed that minimum distance between a participant and a virtual interaction partner was significantly greater when that virtual human appeared to be of an ethnic minority status. So meaning that by tracking people's walking behavior, they were able to detect and express bias against members of this minority group. Now, in a Dutch study, researchers used an established measure of implicit bias called the IAT. Some of you may be familiar with that. They showed that the behavior in VR, the walking behavior, was correlated with the IAT in the expected way. So those participants who had more implicit bias, as shown on the IAT, maintained more distance from a minority group virtual human. Finally, for this area, my colleagues and I found that when participants kept more interpersonal distance from a minority group virtual human during a sort of introductory social interaction, it was predictive of more aggressive behavior towards that virtual human in a later encounter. So we can move on to the next set of psychological outcomes. These relate loosely to evaluation and effort and performance, sort of a broad category encompassing essentially elements related to task performance. So here, these inferences from the data can be really useful in helping us to design educational VR, health interventions, and so on. So again, we'll start with a deeper dive into a study from my lab. Here we used a VR buffet tool that we validated to measure parent food choices in terms of food for their child. So let's think about why measure VR behavior in this context. Well, dietary choices obviously are really crucial for our health. This is especially true for developing children, but it's really hard to change people's behavior related to their diet. You may have experienced that yourself, right? So part of this is because our food choices are not really one single choice. They're a process of these little micro choices that we really need to dig into to understand how we end up choosing the array of food that we do. But our standard measures of food choice in eating don't really give us access into those processes that make up the sort of the whole of the food choice behavior. So they don't really give us the information we might need to think about ways to potentially intervene on these processes. Behavioral data from VR can give us that. So we'll look now at a study where we use the VR buffet to measure parents' food choices after they received some health information about their child. What we did is we went on to look at the behavioral data tracking to determine whether and how physical movement related to parents' thoughts and feelings about feeding their child. So in this study, what we did was we quantified physical walking movement in terms of path tortuosity. So path tortuosity is the degree of straightness or curviness of a walking path through space. The top image there shows the least tortuous path that was taken through the buffet. This is obviously a top-down view of the buffet that participants never have. The bottom image shows a more tortuous path. Now, what we found was that parents who walked a more tortuous path reported feeling less guilty about their child feeding choices in questionnaires that we administered afterwards. And this was true regardless of the objective healthiness of the food that they actually chose. So here we believe what's happening is that this movement around the environment is associated with perceived effort. So how hard parents are really feeling like they tried in the VR buffet to make a meal for their kid. So let's look at a few other studies in this area. So from perceived effort to actual performance. So work by Andrea Stevenson-Wan and colleagues found that body language of teachers and of students during instruction in VR predicted higher low learning success. More data from this group showed that at the dyadic level, synchrony of gestures between two people predicted a pair's creativity level in an activity. And finally, work by Javan and colleagues showed that tracking data from head movement and eye openness and mouth openness was related to task performance over the course of a task, and that these metrics could actually predict errors seconds before they occurred. So the final category we'll look at here is emotion and nonverbal leakage. So we can think about this as how our behavioral data can give us insight into users' emotional states and other implicit mental processes that individuals may or may not be aware of. And this can give us insights into these sort of inner workings of the brain in this regard. So data from a study at Stanford exposed users to a series of 360 videos and demonstrated that the amount of head rotation was associated with higher ratings of pleasure during a 360 video. In another context, Juan and colleagues found that the same type of sort of head scanning movement in a classroom setting was associated with higher anxiety. So this here is an example of where the same type of behavioral measure has a completely different meaning, depending upon the context of the VR environment. Even further, work out of the University of Arizona demonstrated that examining behavioral movement data allowed them to see distinct differences between truthful and deceptive behavior. And this could be identified from video data looking at head and hand activity. So overall, this sort of sampling of studies that I just showed you shows how harvesting and analyzing VR behavioral movement can allow us to infer emotional state, biased attitudes, perceived effort, performance, and so on. So this is how we can begin to use the data to understand the mind and to build really great things in VR. And also, we can use it to start predicting people's behavior in the future, both inside of and potentially also outside of VR. So now I'm going to switch gears just a little bit and talk about VR behavior tracing to indicate health and disease status. So probably unsurprisingly, VR has been proven to be very powerful in medicine as well. This has been true as we strive to understand and diagnose diseases and health conditions and to create treatments that lean on VR as a very powerful technology. Now, partially this is because behavioral data has a lot to tell us about physical and mental functioning of individuals. So let's go ahead and look at a selection of these studies to see what the tech is capable of in this area. So we'll start going a little deeper into one study associated with my lab. Here we work with Skip Rizzo and his colleagues to bring their virtual classroom environment into a longitudinal study of kids with ADHD at our institution that's headed by Philip Shaw. So why look at behavioral data here? Well, we know that kids with ADHD perform worse on attention tasks. It's well established. You all probably know that. But what is the mechanism for this? That's really much less well understood. So here we were examining head movements for visual attention behavior, and that helped us to test theories about these mechanisms that aren't all that easy to test in an artificial lab setting. So in this study, we looked at the head movements over time in a group of 85 kids with and without ADHD. They were in the VR classroom doing the attention task. Overall, we found that kids' shifts in field of view were quantifiably different between kids with and without ADHD, and that these shifts partially explain the link between their diagnosed hyperactive impulsive symptoms and the deficits that were seen in their attention. So now that we know this, we have a possible target for intervention. So we could try to help kids improve their head control or find ways to redirect their field of view to help them pay attention to sort of the things they need to be looking at. Both of these, by the way, could potentially be done in VR-based interventions. So a few more examples to ground this idea. So in the context of autism spectrum disorder, a 2013 study by a group from UC Davis found that children with high-functioning autism spectrum disorder looked less frequently towards virtual classmates compared to typically developing children, and could thus be differentiated. In the context of schizophrenia, a Korean study found that individuals with schizophrenia displayed significantly less eye contact or eye gaze during a virtual conversation than those without schizophrenia. And this was especially true in negative interpersonal situations. And finally, recent data suggests that VR tracking data can also be used to predict mild cognitive impairment. So this study by Howitt and colleagues showed that performance on a walking-based VR navigation task was highly associated with early markers of cognitive impairment. So from these examples, I think we can see that VR data absolutely can be medical data. Now, it's important to note that most of these examples are based on maybe a few studies at best, and there is still a lot more work to do to validate these relationships between behavior and VR and the psychological and health states across people and across time. But in terms of what's next, validation of VR behavior as valid and reliable indicators of these outcomes is certainly something that's in the pipeline. Capabilities will also be expanded through the addition of sensors and addition of data streams, as we talked about earlier, and machine learning approaches will expand and grow, leading to the ability to extract more signal from the noise. So we absolutely expect these prediction models to get better and better over time. For this reason, it seems especially crucial that we effectively protect our VR data. And in this context, we are protecting this information. Within the infrastructure for research and healthcare, there are, of course, many layers of regulations and requirements to ensure good use of our information so that it helps individuals and helps the public good. This is going to be a really familiar world to many of us as researchers, and hopefully it's also a familiar world to us as patients as well. Take a quick refresher just to remember what these sort of layers of regulations and requirements look like. So in the US, all medical health care data are governed by a rule called HIPAA. This regulation is there to protect patient rights. So these include things like providing rights for patients to get copies of their medical records, to make corrections to their medical records if patients think that they're incorrect, to receive notice of how health information is used and shared, to learn why health information is shared, and to decide if patients want to give permission before their health information is used for certain purposes, like marketing, for example. And this has generally been considered to be pretty strong privacy protection. But interestingly, and I just found this out a couple of years ago when I started looking deeper into HIPAA, it only actually applies to health and medical information covered by, held by what they call these sort of covered entities. And what are covered entities? Covered entities are healthcare providers and systems, health plans, health insurers, and their sort of direct business associates. That is it. So that doesn't include employers, life insurers, law enforcement. It doesn't include researchers. So foreshadowing a little bit, this narrow definition of who HIPAA applies to does not apply to the way that tech companies collect and process health information or medical information, which has caused some experts to say that HIPAA may actually be somewhat outdated. So what about research? So we talked about healthcare. What about research? Research data is not bound by HIPAA, as we've just learned, unless it's happening in a healthcare context. Now, most of us know health data are regulated by IRBs, institutional review boards, whose job it is to protect the rights and welfare of research subjects. So for example, IRBs make sure the risks of research are reasonable in relation to the anticipated benefits. They make sure that participants are fully informed about risks and they consent to these risks. They make sure there are adequate protections to the privacy of individuals and the confidentiality of their data. So privacy-wise, IRBs tend to protect personally identifiable information, which as researchers we probably know as PII. If you're not familiar with that, it's information that can distinguish or trace an individual's identity, either alone or when combined with other identifying information. So for this reason, PII has to be determined on a case-by-case basis. Examples are things like your phone number, your voice print, your IP address, your facial geometry, also things like geographical indicators. But researchers increasingly need to share data to do our jobs. And there are actually increasing federal recommendations and requirements that we share our data. So how do you do this without endangering patient privacy? We anonymize. So we strip PII from the data. And at that point, anonymized health data and other data are not considered to be personal information, and they are not covered by privacy regulations, which has been fine. So for a long time, probability of re-identification of anonymized health and medical data has been really small. Even so, there have been some examples of re-identification of these anonymized data sets that were sort of proof of concept things done by academics, occasionally by reporters. But more recently, you'll be unsurprised to hear that probability of re-identification is actually getting much higher. So here's just a little example of how, as it turns out, it actually doesn't take that much information in combination to make an individual identifiable. So this is based on an interesting body of work by Latanya Sweeney at Harvard. This is a tool from her group that demonstrates how combining demographics like date of birth, gender, and zip code, which are things we often collect as researchers in a lot of contexts, can frequently render an individual identifiable. This is obviously not my real information, but there's apparently only one of this person that exists. So this is just an example of how, with different streams of data, re-identification might be getting easier. So what's happening in this area? A lot is happening in this area. So I'm going to give you one example. I mentioned that tech companies, but also insurance companies are buying anonymized medical data for various purposes, right? They have to train their algorithms and so on. Now, there have also been recent reports of insurance companies buying data on people related to things like social media use, online purchases, and so on. So there are obvious concerns that these data streams could be combined and used to do things like achieve re-identification in health data sets. But sometimes you don't even need to get that complex with the data streams. So here's another example from the world of genetics, the world that I live in most of the time. And it turns out that a lot of people have posted their genetic information that they've gotten from sources like 23andMe. So they've taken that data out of 23andMe and they've put it into these open ancestry databases to try and sort of maximize their reach, when it comes to finding matches and family members for the world of genealogy. But of course, DNA runs in families, right? So because of this, researchers have now shown that more than 60% of Americans with European ancestry can be identified through their DNA using these open access genealogy databases. And this is regardless of whether that particular person's DNA itself was ever actually tested. Now, since that time, because of some law enforcement use of these genealogy databases, which you may have heard about, there's been some increased protections of the data, but the cat might already be out of the bag to some extent. Taking it one step further, this is a paper from an industry-based team that has reported on ways to predict people's traits. So things like skin color, eye color, voice characteristics from their DNA. Now, DNA contains a lot of personal information. The predictions aren't that great yet, but it's not far-fetched to imagine similar things from the future of VR data, especially when those data interface with other data sources. All right, so where are we now with VR data? Like genetic data, anonymizing VR tracking data is really hard. It's nearly impossible because all individuals have unique patterns of movement. So research has explored the possibility of using VR behavioral tracing as even a unique identifier of individuals. So I'm showing you the data from one study here where researchers measured the motion involved in throwing a ball at a target in VR. So they achieved identification accuracy of about 93% using 10 trajectories per subject. And this is not the only study to show this. New research is starting to emerge, showing that users in an even larger pool can be identified at high accuracy rates within very simple VR environments. So at the end of the day, VR tracking data should potentially be considered PII. This is something we should talk about because it can be used to distinguish or trace an individual's identity alone, but especially in combination with other personal information that these systems may have. So that brings us to our next key point. This is the dual use nature of VR behavioral tracking data. In other words, what provides power for social good can provide power for social ill. So now let's look at these issues in the context of commercial VR. And for the purposes of this talk, what I mean by this is VR use at home, at work, in training scenarios, basically everything else that's not research in healthcare. Data from these contexts aren't covered by the regulatory frameworks of research in healthcare that I just talked about. So are people aware of potential privacy issues in VR? If we look to the general population, this study did a survey and the answer seems to be no, they are not aware. This is survey data from 2019 and it shows VR ranked at the bottom among biosensors in its perceived ability to reveal information about people's personal thoughts and feelings. Even stuff like oxygenation sensors and things seem to be more revealing to many people, which I'd argue is really pretty off base. Interestingly, if we look at the top of the most highly ranked biosensors, body language is up there in basically the #2 slot. And of course, body language is part and parcel of VR use and VR data tracking, suggesting that from a privacy and a security standpoint, people are probably viewing VR as pretty passive, like a movie screen on your head, and not at all as the dynamic system that it actually is. So this is a perception that's going to need to change. What about those of us who are more familiar with the tech? This recent qualitative study interviewed VR users and developers, and did find that privacy was a major concern for many people. But still digging into the qualitative data a little bit, they revealed that participants were most worried about the mic and the infrared camera rather than the sort of behavioral tracking piece. And some people still reported that sort of age-old notion that, why would I need privacy if I'm not doing anything wrong, right? Still, other people felt like this current state of the VR technology was too new and too soon to really worry too much about privacy. So again, I think there are some misperceptions, even among people who are relatively familiar with the technology. And I'll argue that this is particularly important, given that people tend to disclose more online, particularly when they feel like they're anonymous. So researchers and clinicians have actually proposed that virtual humans might be ideal for soliciting personal information and self-disclosure from patients. You have the human-like characteristics, along with a higher perceived anonymity, because these things are happening online. So I have up here is data from Lucas and colleagues who found higher willingness to disclose personal information to a computerized virtual human than a human-controlled avatar, and also showed that a computer-based VR interviewer solicited more symptom reporting from individuals with PTSD symptoms than they would get through other more standard or even anonymized data collection techniques. So in some ways, we could be setting up this sort of perfect storm where VR environments are digital and they're online, and they feel more anonymous and they can elicit disinhibited behavior, when in fact, they're actually better equipped to collect and analyze that behavior than any real world environment. So finally, what do users think is right? So I'm showing you survey data here from Jessica Outlaw on a sample of VR users. And what her data shows is that users of VR feel like use of personal biometric data for product development, to some extent for market research, is relatively acceptable. But they generally felt that the sale of those data was unacceptable, even when they were anonymous. So this gives us some sense of what consumers want, and to some extent, what they might expect or assume. So this brings us to the dystopian part, the why worry part. So in considering these potential futures, these are what we sometimes call the Black Mirror scenarios, things that could come to pass given VR's current and future capabilities. So I'm going to read you an example from an article that I worked on with some colleagues that was printed in the World Economic Forum agenda. And the story goes like this. So it seemed like a game when Riley first started up the virtual reality maze. He used a room scale setup, so by physically walking around his living room, he could solve puzzles and visit different parts of the virtual maze. His friends were networked into the game, so even though they were in their own living rooms, when Riley turned his head, he could make eye contact with them. He could even give them virtual high fives. Slapping avatar hands gave him the sensation of haptic feedback in his controller. What Riley didn't know was that the startup that created this game had decided to sell its users tracking data. Riley also didn't know that a 20-minute VR game session recorded 2 million points of data about his body movement, and that an insurance company was one of the customers buying the game data. A month after playing the game, he was turned down for a new life insurance policy. Given his excellent health, he couldn't understand why. Several appeals later, the insurance company disclosed that Riley's tracking data from the VR maze game revealed behavioral movement patterns often seen among people in the very early stages of dementia. Later, Riley's sister, who had not played the VR maze game, was also rejected for life and long-term care insurance policies, as dementia tends to run in families. So there are a lot of scenarios like this that you could imagine. The possible harms are kind of diverse, but they fall under a couple of primary themes. So we'll just go through those two themes. And the first one involves classifications or decisions that might be made using personal data that stems from VR. So the use of Riley's data in the story I just told is one example of that. Another example that people talk about a lot is that behavioral information, like gaze data in an interpersonal VR environment, might give information about a person's sexual preference, sexual orientation. If this were tracked and used in certain countries or certain contexts or cultures where people whose data suggested they were gay could be persecuted. And of course, once the data are collected, it may not just be a company, just a company or a government using these data to categorize people or to make decisions about them. Data can also be used illicitly, of course. Could be exposed through hacks or data breaches, which seem to happen all the time. The other theme is use of VR behavior in essentially closed loop systems. So VR environments that learn through tracking your behavior and then adapt to use that information in order to influence your future behavior. So I'm going to give you a more positive example. We'll lighten up for a moment. If you wanted to use VR to help people do more physical activity, and my data in an exercise game shows that I tend to swing my arms, higher and faster, and my heart rate goes up more. When you put targets up high rather than down low, you could increase the incidence of those high up targets to increase my physical activity. So I would probably consent to my use of my data for this kind of purpose. But of course, we can use it for questionable or unethical kind of purposes here. So we can think about intensive marketing, the use of personalized stimuli in VR environments, could manipulate users through, yes, targeted advertising, also through tailored avatars that use mimicry and other social techniques to try and be persuasive. Another thought is that through learning about one's emotional triggers, somebody could embed those triggers in a VR environment to make users angry or afraid. And in psychology, we know that people who are angry or afraid act differently. They pay attention to different things, and they have different tendencies in terms of what their behavior is going to be. So this could help to trick users into acting against their best interests. Some people have even speculated this could be an effective route to radicalization. So the bottom line here is that the use of VR for these purposes could create this sort of false sense of agency, right? Where people think that their actions are autonomous, but they're actually manipulated and shaped by personalized adaptations in VR environments that are designed to elicit specific behaviors or specific outcomes. All right, so move on to the third point. This, of course, does not have to be our future. There are ways to mitigate potential future harms. Now, mitigation is a really multifaceted and evolving area. There was a fantastic panel on it yesterday. View the recording if you didn't catch it live. Honestly, it's not as much of an expertise for me, but it would be totally irresponsible to just stop at the dystopian part. That would be depressing. So thankfully, there's a lot of really smart commentary here from which I drew heavily in putting this together. I also want to point out that a lot of this thinking in this area was sort of influenced by a landmark summit at Stanford University in the fall of 2018. It was attended by a lot of AR and VR folks in hardware and software and academia, nonprofits, and so on. It's where a lot of us really started to get our arms around some of these issues. So I'm going to cover just a few of the main points related to these efforts, but know that there is much, much more that I'll be able to do justice to here. So some of the conversations I won't go into detail on relate to things like data sovereignty, data rights, can we sell our data? Is it our property? There are philosophical and practical concerns with that, including the notion that privacy could then become a luxury for the rich. There are other thoughts around how to make business models that prioritize privacy, ideas around decentralization, identity verification, the possibility of having multiple personas, algorithmic guardians. The takeaway is that there's no shortage of good ideas to move us forward. But I'm going to dig into a couple of the sort of biggies on the left here. So I'm going to start by looking a little bit at data collection standards. So there will be a need for companies to collect some data, right? They need to improve their products. They will probably need to advertise under most business models. And I don't think people are really suggesting that no data should be collected. But as of now, there are no standards in terms of what data should be collected from users' VR systems and in what way. So some of the primary questions related to these standards are things like the acceptable granularity of the data to be collected, whether companies should collect raw data versus processed data. Might most legitimate uses of VR data only require information that's derived from the data, such as when or for how long a user's field of view intersected with a virtual object, or when an avatar collided with a key object, those sorts of things. Other questions surround how long the collected data should be held. Could it expire automatically? Should it be deleted? If not, companies could amass these very large and powerful longitudinal data sets about us, over years. So a common refrain in this space tends to be, don't collect what you don't need, right? Because if data aren't collected in the first place, if they sort of disappear into the ether, then we don't really need to be concerned about how to keep them private. Now, privacy policies are where these data collection practices can become transparent. I'll say can become transparent. So a 2018 review of privacy policies in VR applications by Adams and colleagues suggested that they were basically totally inadequate. They were missing critical elements. Some of them didn't even reference the fact that VR was involved. They referenced only the non-VR version of an app. Part of the problem, again, is a total lack of guidelines and norms. So there have been calls for creation of templates and example ethical privacy policies that would be agreeable both to users and to industry. There have been a few attempts at this. I don't think anything has really caught on yet, partially because another issue is that privacy agreements can't really be one size fits all. VR applications produce many different types of data, have different data needs, so on and so forth. So with this in mind, an idea that colleagues and I have written about is to have independent IRB type governing boards that review privacy policies, ensure that they're adequate to protect user privacy. So this is one of these ideas that emerged out of that summit at Stanford. Unlike general ethics boards, these IRBs would be concerned primarily with user protections and so on. But even so, even if we come up with a great privacy policy on paper, for policies to be truly ethical is going to require real informed consent. So the bottom line of informed consent is that it requires genuine understanding. Clicking the button at the bottom of a privacy agreement is not informed consent, whether or not people have read that privacy agreement, because we know people don't read them for very, very good reason. Also, policies and their enforcement can change, often with minimal notice, sometimes no notice to users. Data can be transferred when one company is acquired by another company without additional consent. And then there's consumer education and engagement. So how can people consent to these if they don't understand the risks at all? If they think VR is the least, invasive of all biometric data. Users are often unaware of the consequences of using, but also of bundling and reselling their data. They don't realize that bringing data streams together can result in the formation of these really comprehensive profiles of them. So this brings up the suggestion that users need tools and clear communication to help them understand their digital footprint. So here are a few examples of this. One example is Lightbeam for Firefox, which no longer exists, but it helped users visualize where their data was going on the web. So this could give us ideas about ways to create tools in the future to help VR users. Another example is an experiential piece called Persuasion Machines, which was exhibited at Sundance back when we could get together and exhibit things in real world, but it is an experiential representation of this. It shows how electronic devices in our life leave behind a trail of data that could be exploited. And then another example is the New York Times Privacy Project, bringing together issues around privacy and bringing it directly to readers in really, I would argue, compelling ways. Of course, you can't fix the problem this big by changing individuals' behavior. So I don't think that is the point of all of this. So this brings us to legislation, which is the biggie. At the end of the day, legislation is probably going to be needed to adequately protect user privacy and autonomy. Now, industry is beholden to profit, right? And so they need to be incentivized to, or required to, enter privacy into their sort of calculus. Governments could also provide funding and other incentives for development of technology to help provide privacy. I think this is an interesting way to incentivize these business models. But I think an important point is that we don't just need legislation, right? We need informed and evidence-based legislation, wherein we, the research community, and others involved in this world can provide inputs into the policy based on the issues that we see coming down the pike. So in terms of existing legislation, we have GDPR in the EU and CCPA in California. I'm sure there are other laws, but these are really our poster children here. And they go quite some distance in regard to protecting user privacy. We'll focus just for a minute on GDPR, General Data Protection Regulation. I promise not too much because it'll get boring. But I just want to point out that it aligns with a lot of the things we've been talking about. So it provides rights that include things like having the right to restrict processing of your personal data, data portability and access, and users own their data. That users can get information about what's collected and how it's used. They have the right to correction, so users can fix problems in the data. This should be sounding familiar from HIPAA, right? Erasure, which is more commonly known as the right to be forgotten, and consent. So consent has to be clear, and consent can be revoked, which is something we see in research as well. Now, this set of legislation applies obviously just to people in the EU, though there are some similar policies, most notably in California, in the US. But in general, where it's active, this type of legislation, can go a long way. And we need more. We need more of this kind of legislation. So to wind up here, during our time this morning, we've considered these 3 things. I won't read them to you again. You've seen them over and over. But I'm going to be unfair. I'm going to ask you to remember a 4th thing. So we as individuals and as a community are in part creators of VR's future, right? So first, let's definitely make sure that we realize VR's promise and the power that it brings for research and healthcare and education and entertainment, and everything else. And we also have a responsibility to make sure that we realize that promise responsibly. When we design our research studies, when we design our VR applications, when we communicate to the public and to policymakers and to other people about the promise of VR, we need to ensure that we're keeping users' privacy and autonomy and any other risks. There are many others. We keep those at the forefront and we consider them. So with that, I will say thank you. I should be able to take some questions now, and also feel free to reach out for questions and discussions at a later time.
All right. Thank you, Dr. Persky, for that talk. And a number of questions have come up while you spoke, and I can see that they're still coming up even at this moment. So a very popular question involves the processing of this kind of data, tracking data of all sorts. And it's difficult to process this data. And you covered many studies where the data was processed and brought to the point of nice, clean graphs with significant effects. Could you mention some of the effective strategies or software that you and your group have used to process this kind of data?
Yeah, absolutely. So that is a really big question. And, for a long time, a lot of us have just been, boiling data down and aggregating the heck out of it, which I would argue is not, the way we should be going forward with this. But, we have our VR environments put together so that on the back end, they are already telling us, what percentage of the time was the virtual patient's head in face in view, during the interaction. So our environments are already looking for that and processing that in real time and kind of spitting it out the back end. So some of these things we have kind of baked right into our environments, and those tend to be the things related to things like interpersonal distance, gaze direction, the kind of measures that are routinely used. Of course, now we're sort of moving into a world where we're going to be looking at novel measures, using more machine learning, using those kind of approaches, and that gets a little bit harder. Our path tortuosity measure, was frankly a measure that one of my colleagues knew about and said, boy, wouldn't this fit the data, the way the data looks really well. And so we just used an R package for that. That had been used in other contexts. So it had been used a little bit with real walking paths of people with brain injury. And it had been used actually to look at the branching of arteries and things within the body. So it hadn't been applied in a VR context yet, but it existed in other contexts. So some of it is sort of looking for measures and ways of quantifying data that feel like they're going to fit what we're looking to do, and others are going to be really exploratory. And so I don't think there's anything existing in terms of a really great data package to do this. Although, I will say that I've seen things on the industry side that are evolving around more sort of market research and usability testing and things like that. And so, I'm less aware of what they're doing in terms of quantifying the data. But, I think this is a really quickly moving area.
All right, thank you. Another question that has been popular from the beginning, and it's not something that you mentioned at all, but have people used this kind of data to study animal behavior, where the gaze and other movements of animals could be used to understand, their behavior and cognition?
Yeah, I mean, that's really interesting. So I know that VR for animal behavior is just at its infancy, but it is starting. I'm aware of caves for zebrafish and things like that. I know a little bit about this. So there are certain kinds of enclosures for mice and rats, for example, that will do this tracking. So it's not VR, but it is tracking within the actual sort of animal environment. So there are certainly things going on. I'm not aware of people bringing sort of the two things together and looking at behavioral tracking of animals within VR environments. There may be, I'm not sure. But I would say that the tools to do this are out there. And this is also something that's starting to happen.
Okay. Another question, also very popular. Is there something that researchers can do now to help consumers protect their behavioral and biometrically sensed data?
So as researchers, I think there are a few things we can potentially do. There's been a big movement throughout research that we should be doing more communication to the public, right? That we should be communicating our science, not just to each other, but also doing outreach and making the public aware of what it is we're finding and what it means, for them and for society. So I think sort of bringing that ethos into, this world, I think could do a fair amount of good. And I have definitely seen some kind of consumer-facing publications that have tackled this a little bit, but not as much as we could see. So I feel like things like op-eds and tools and things like that. I think those would be really fantastic and really welcome. I think, as we talked a little bit about yesterday in the privacy panel, a lot of this is going to boil down to using our science to inform policy. So also, not going directly to consumers and to the public, but also trying to go, to policymakers and inform them of, sort of what's potentially coming down the pike. Would also be another important way to go. And then to just keep doing the research. So the more we know about the possibilities, the more we develop the possibilities, and think about how to use them ethically and what kind of protections we might want to put on them, the more that we can understand these issues and know what's possible. So I think it's kind of a three-pronged approach. There are probably other things we can do that I'm not thinking of right now, but I think even just having this conversation is important.
All right, thank you. Another question, also popular. When this sort of data is used to make a medical diagnosis, and what, in your opinion, is the bigger threat? Predicting a true positive or a false positive?
Right. So I would say most of this, is still very much within the research sphere. Very little of it is actually being used in medical settings as of yet. I feel like part of the perceived benefit of using VR for these sorts of things is to catch potential cases early. So if we look at something like the mild cognitive impairment case, if we could say, hey, we downloaded your data, there's a chance, your chances are elevated. Why don't you go in for, the standard kind of test? Then that might be beneficial. So I'm not sure that right now we're at a point where we would be doing a lot of diagnosis directly through VR, although we could certainly get there in some cases where it would make sense. And people are certainly working on that. But I'd like to think that the things that actually are going to involve diagnosis and such would be going through an FDA sort of route, a route where they are actually required to prove efficacy and show that the false positive, false negative, true positive, true negative rates, are within the thresholds of what they should be. Because it's important to catch cases, but we don't want to tell a bunch of people that they are coming down with health conditions when they're not. So I think just being really responsible about how this would roll out is the most important thing.
Okay. Another question. So many of these experiments that you covered involve people doing some sort of special activity, part of some experimental protocol. What about the data that comes from what we could call normal VR interaction? So for example, in this very conference, many of us are putting on head-mounted displays, interacting with each other through Mozilla hubs. That data is going somewhere, at least to get rendered. Mm-hmm. And we could consider those normal interactions, and that we're just talking to colleagues, looking at posters, things like that.
Right. So, so anything we're going to use as a measure of something should, of course, be researched and validated. But I would argue that maybe you're approaching some colleagues closer than others. Maybe you're looking at certain parts of a poster more than you're looking at other parts of a poster. I do think that these data, do have meaning. And were they to be collected and analyzed, they could probably tell us something about people's psychological states as they're going through the course of their sort of normal interaction in a conference. It might be something that you would see as relatively innocuous. Do I like, Kyle better than Diane or Diane better than Kyle, right? Or, what part of the poster do I find most interesting? But they don't always have to be that way. It just sort of depends on what we figure out that we can tell from those data.
Okay. I think I have time for maybe one more question. And so, are there any thoughts about the right way that we, as researchers in this field, could anonymize our VR data? Motion and eye gaze, I guess, are the primary data that this field is currently collecting.
Right. I think, I talked about how difficult anonymization is. And that's not to say if you just have data, on behavioral movement all alone, that it's going to be re-identifiable. I'm not sure at this point that that's the case, especially coming out of a lab, not attached to an IP address, not, things like that. But as researchers, we tend to put our data out there. We anonymize it. So we take out things like zip code and birth date, and any identifiable data. And then we put it out there in a big sort of mass, or at least that's what we tend to do in these databases. Depending on how deeply we think about anonymizing our data, we may need to think about sort of trying to go further. So if we're going to put out behavioral data alongside questionnaire data, demographic data, things like that, I think we really need to think more carefully about, sort of user demographics and things like that going out into sharing situations. I don't know much about technical ways to think about anonymizing data a little more, transforming it, things like that. Those are potentially things people could think about. But I think we just need to be really mindful that when we share data and put it in these databases, or put it out when we submit to a journal and they ask us to share the data, I just think we need to be really mindful about what's connected to what, and whether bringing the streams of data together could render somebody identifiable.
And that answer, I guess, interacts with the reproducibility movement,
right,
in science, which calls for more data. So thank you, Dr. Persky, for that talk.
All right, thank you.
And I will make one more announcement. So immediately following this talk, the next poster session begins. And we would appreciate it if those watching could join. We would, within hubs in particular, and we would like to continue to load test hubs and maybe bring it to the point where we find out what its limits are. But also, please don't just go to the first room in the list. The posters are spread across all the rooms, and there's a tendency to just jump into the very first room. But there are people presenting their posters in all of the rooms, and you can go directly from the list of posters with a link to each room and the list on the conference website, ieeevr.org/posters. All right, thank you again.
Thank you.